in middle the four are available, vinyl logs, and we use the density, neutron porosity, and deep resistivity and gamma ray from the vinyl logs, and the core data as a flag and its description to define the geometry and the lesser types of the Lockhart formation for their facies. We opted the deep resistivity because it has some very detailed and precise information, which is a bit more informative than other electrical logs. The total of 100 iterations are used for the lithofacies classification. The electrofacies predicted from this process are 5, which are in agreement with the core description, which already also describe the 5 different types of the area in the Lockhart formation. The objective of this analysis is twofold: to rectify the subdivision within the reservoir rocks based on geophysical well logs, and also secondly to assess the distribution of various types as defined for the Lockhart formation in the area. These are the input logs on your right side of the screen, and the lower photograph is about the statistical mean and mean values for the mean and variance values of input logs. The methodology we adopted, this is just this description of the 3 stages we adopted for the to go for the electrofacies prediction, which has the data analysis. The first one, take the data and clean it any outliers. Then the model definitions, the training part, and the model application, lithology identification scenario. The first picture of this nodes are there. That is the first step when you introduce the data to the SOM machine learning method. So it generally indexes the data and accumulates information. In the second phase, we take when you execute the process, it takes the neural networking. Process, and then in the next stage, the indexation process takes place, and the model refinement. And in the third part, when you are done with all the data analysis, data refinement, and then apply the model application. And the rightmost side, you can see that these are the results of the SOM in your in that rightmost corner. These are the scenario we have just discussed. It is a regular process, but we have done a little bit more, the advantages of the SOM and how we have predicted the facies, a little bit more refinement of the process. The hierarchical clustering method is used for this particular project, which has the algorithm involves iterative grouping the most similar samples, resulting in a dendrogram that assists in determining the optimal number of the facies. And it takes data from the lower side to the upper levels. This is the actual framework of the data, because the information is too large for in the electrical logs, and they have been quite very different physics. Acquisition is very different. Electrical logs, nuclear logs. So when you introduce this data to the SOM machine learning process, it accumulates all the information with the similar properties and group it into for a particular precise information. That can be your predicted group of information that is accumulated, and that can be your facies, any kind of set of information. So for example, on this left side of, you are introducing a lot of big number of the information, which is in the form of data, but when you run the SOM process, it takes the data out and gives you the precision in the end that the 25 clusters are there, 6 clusters are there, 10 clusters are there. That's how we take the journey from this side to the other side. This is just the example. Every node has some information, but how many variables you are introducing, it is reflected in the nodes, and as you see that every single node has four sets information. For example, the variables we are introducing, and it is reflecting how much data is coming from which side. So when you are done with the this all training process. Then the statistical results are there for you. You can understand the modalities, samples, and mean and variance of each input variable and within the range of modality. The variable ranking is like if it is below 0, then it is over exaggerating, and if it is going over 1, it is the data may be redundant. So the number should lie within the range of 0 to 1. The information column denotes the contribution of each variable to the classification. Core data integration. When we are done with this process and core data was introduced earlier, but when the facies are predicted, then we have done another step for this information of when we achieved from there. We took the data from the core description. We basically identified these facies, then quantified the results, and then classified the facies, giving them the codes, colors for the field development plan. The one-dimensional topical structure of the system aligns with the geological lithofacies for the area, which is supported by the core information. The Western Salt Range region 5 distinct facies for the Lockhart formation. And this chart is showing that how we have classified the leftmost side, the facies 1. Facies 1 is identified as a poor one when it is distributed along the 4 wells. It has the facies 2 is the fair potential of the reservoir, fair to poor, but the facies 5, 4, 3 are relatively high. The facies 5 is identified as the one of the best in the study area, and it is supported by the production data. We will go to that slide.